So, welcome everyone to the Altius podcast series, where we break down the technology side of Web3 and explore what it really takes to build fast, scalable, and user-ready blockchain infrastructure. In this series, we are sitting down with Anit, co-founder of Altius and CTO, the former HFT system engineer, to dive into everything from the modern software architecture to mempools, modularity, and beyond. So whether you are a developer, founder, or just Web3 enthusiast and curious how blockchain actually system works under the hood, you are in the right place. Let's jump in. Hello, Ani.
Hey, Ivan.
Hey,
Good morning.
good morning. Good morning. So let's try and figure out today what Web3 can learn from HFT, because you've definitely spent some time there. And based on my understanding, high frequency trading firms, they spend millions shaving off milliseconds. So like they really care about the speed. And that's maybe why everyone should be excited about Altus and what we are building, that we bring this knowledge into the Web3. So what can blockchain learn from that world? Walk me through, please, as a 5-year-old kid.
Yeah. Well, first, I want to not to stand you up. I want to correct you. They spend millions to shave off nanoseconds. Milliseconds are way too. But yeah, I mean, HFT was. I mean, it was such an amazing time to work in that industry since I got to work when it was kind of in its nascent beginnings. You know, remembering kind of where we, speaking to your point, initially when I joined the industry, we were, looking at can we save milliseconds here, and then a few years later I went to can we save microseconds here, and a few years later I went to okay, we need to like shave off a nanosecond here or there, and uh, yeah, obviously they went kind of like the Bitcoin world went, right? Like you keep on getting more and more specialized to speed up tiny parts of the system. So for example, obviously Bitcoin, they went to making their own ASICs to be able to mine Bitcoins more cheaply and effectively. And for the same thing in the high frequency trading world, they also started with software. They optimized the software. They realized it'd be faster to enable more special purpose hardware for that. So then they started using FPGAs, and then it got to the point where it would actually, even though printing a custom ASIC is a huge cost, right? An FPGA you can actually and for those of you who don't know, an FPGA is basically kind of making your own hardware board using typically VHDL, which is the design language, kind of like imagine C++ or Java or something like that, compiling it into something, and then out pops hardware. That's basically a hardware board that is optimized to do the thing that you want it to do. In our case, obviously, it's just to facilitate trading. So what I'm saying is that that has a cost because it's a slow development cycle, and then they moved on to making custom ASICs, and that at that point you have to print a board, not just rewire kind of a board and software, which then kind of becomes fast acting hardware. You have to print the hardware. You go to Taiwan or somewhere that prints boards and literally like print a board that you can then plug into a computer and make things even faster. So as you can see, like they went more and more and more specialized. So I think, to your point, Ivan, like, there's all these things that we did in HFT, and a lot of these things are shared with the Web 2 world. Maybe not down to, or actually, I'm not as familiar, but down to the custom hardware level is also shared in the Web 2 world to try to minimize costs and bring scale to your system. So a lot of the things we used to do, it was just trying to optimize every little part of the whole end-to-end solution, right? And I think in the blockchain world, we've been doing something similar, where we've focused on various different parts of the problem. First, there's been different cycles, ups and downs in kind of like in the crypto industry where we focus on consensus. People are focusing, at some point, everything went to a lot of emphasis was put on layer twos, and there still are a lot of emphasis on L2s where we can, maybe speed up some portion of the transactions and then settle back on an L1 like Ethereum. So a lot of the stuff is we're also attacking in the crypto space, and I think from at least my experience in HFT, where I worked a lot on distributed systems, a lot of distributed caching infrastructure for to speed up basically market data simulations. A lot of those kind of tactics and tricks can be applied to what we're trying to do here at Altius, which is speed up execution and do a better job of managing state. There's various levels of optimization you can do when you get to kind of any piece of software that's managing a lot of data and running transactions like we are in the crypto world. There's simple just optimizations in terms of there's different levels, right? So like kind of the first level is the dumb stuff where, okay, I don't need to run this particular code over and over as many times, or I can do it using an array versus, some other data object or data structure that is a little bit slower. So that's kind of like the dumb thing where it's just like fixing your own kind of simple mistakes maybe to make things faster. And but then you get down to the next level, right? You're getting down to, can I optimize this by making sure that things are in memory more? And so that's one of the areas that in Altius we're definitely, that's our first step, is to really focus on making sure that everything is in memory. Because in HFT, let me take that back. So in HFT, we got to a point where we knew enough about what was coming in terms of trading or whatnot, where everything was in memory, right? Just absolutely everything you needed and wanted was in memory. There was no disk touching at all whatsoever. It's a slightly different space. You can't just put like a 10 terabyte database, like for example, like all the blockchain data into memory and just that's fine. So obviously there's some different problems we have to tackle over here. But, again, it comes down from that idea of, you need to make sure everything is in memory. So let's try to do our best that we can to make sure as much as possible is in memory, or at least it's in memory before we need it, right? That's kind of the main goal here. And so that's kind of one of the main things that you can do next in terms of optimization. How much can you cache in memory? And then I could go on to the next steps, which we have not personally even thought about yet. There's enough work to be doing at this level. But HFT, they continue down the road, right? I mentioned earlier they do FPGAs, ASICs, but also we start looking at like what kind of caching is happening at the processor level. Are you having to even going to memory becomes slow in the HFT world? How can we prefetch things to make sure that the cache in the processor, which is much faster than main memory, what can we do to make sure that we make that happen as often as possible? Now, again, these things are a little bit easier in the HFT world because you have a better idea, the shape of what is coming at you, right? It's market data, as you make a decision, and then based on that, you place an order, and then you continue reacting, right? Rinse and repeat over and over in that cycle. Obviously, blockchain is a little bit different because you can have different smart contracts that run, and you don't really know which one is going to run next. But as I mentioned, the first step is to let's see if we can get everything into memory, and that's kind of the biggest lesson that I took away from my time working at HFT. And for example, for our distributed cache, we started with spinning disks because you couldn't afford that much memory at the time. And so just in the same way, we need to change here, right? Like for a long time, the state was small enough that SSD was fine, but that is no longer the case. Now our state is getting too big, and even SSDs are too slow because just to load a single account, for example, in Ethereum, you may need, I forgot what the number is, like 17 SSD accesses. And so if you could just get that by going to memory once, then you're in much better shape. So I hope that we can solve these problems to start with in the the blockchain world, and then hey, maybe we can move on to the even more fun, cool stuff like optimizing cache lines and things like that at the processor level. But baby steps, one thing at a time.
It's crazy to hear how many things I discovered just within the last few minutes, and realize that within the more than 10 years of building blockchain, we still have to make these baby steps. That's very inspiring and interesting to hear. Yeah.
Which I think
Before.
is which I think is totally okay, right? I mean, it's just all these other industries made the baby steps as well, and every industry has to do that because to some degree, you can't just make all these steps at once because you don't know if you're doing it right. I don't fault the existing infrastructure right now in blockchain. It's fine. I mean, you have to do things to prove to yourself they're correct. And if you take all these steps and lump them all in together at once, you're probably doing something wrong, and you'll probably end up, corrupting the chain or whatever, which obviously has very, very serious implications. So, but we have chains that are functioning correctly, and we just need to start adding these baby steps to the system.
I see. Yeah, makes sense. I'm curious. So most of us who are maybe, let's say, not that tech savvy, we know that infrastructure is important, maybe as well as the smart contract efficiency. But I'm curious, it's easy to get caught up in writing maybe perfect smart contract, but it seems like the infrastructure is playing even the bigger role. So my question is like, what do people often miss when it comes to network performance? Should they probably dig deeper into the infrastructure and execution part? Tell us maybe more about this. So like why network infrastructure is as important as smart contract efficiency in this performance?
Yeah, that's a good question. And in the HFT world, they spend an incredible amount of time. Again, as I mentioned earlier, and thanks for bringing it up, Ivan. I didn't even mention networking. I mean, the stories I have about how there was a company, and unfortunately I can't remember the name. And anyways, even if I did remember the name, let's just say there was a company that did very well at trading futures in Chicago versus basically the S&P mini futures in Chicago versus the S&P index over in New York on the NASDAQ. And for the life of us, our traders couldn't figure out how they were always beating us to the trade. And then one person came up with the idea that, it all came down to the speed of light and how fast you can take data from New York to Chicago and back to be able to place that trade and make money. And what it came down to is someone kind of realized that they were always beating us by like almost the exact amount. And I don't remember exactly how it went down, but it was kind of it was something along the lines where like they literally looked at a map, and they looked at the existing fiber line that we were using to get data back and forth. And then what ended up happening is they're like, I think they have a straighter line. Like someone has a secret fiber line that's straighter than the one that all us other chumps were using. This super slow line that was like maybe like a whole half millisecond slower or something like that, which is big in HFT. And it turned out that was true. The company that was just eating our dinner every day for breakfast, lunch, and dinner on that particular trade, they just had a faster line, and it was slightly straighter. And then from there, they moved to, okay, how do we do microwaves? Because microwaves are faster. So then they installed microwaves all the way from New York to Chicago. And then, obviously like straighter lines going across the Atlantic, straighter lines going across the Pacific, like literally boats that are deploying fiber across the ocean floor. I digress a little bit, again, a little bit of nostalgia there, but these are things that matter, right? And HFT, obviously, the margins are so important that spending millions on these types of infrastructure are worth it, right? Otherwise, they wouldn't do it. So it's a little bit harder in the blockchain space. And folks like Double Zero, they're doing something really cool where they're trying to bring this kind of HFT level of guaranteed bandwidth and latency to the blockchain. And obviously, they're focusing on Solana first, but I personally hope that they eventually have a big enough system that they can open it up to any blockchain that wants to rent lines from them. So I guess the problem becomes is that it's hard for a single validator or a single node operator to lease a very fast line, and also on top of that, it depends on who your peers are. If you're gossiping with a whole bunch of different nodes and machines all over the internet, that's a little bit hard. What we would like to kind of focus on is that what we did find at HRT is, in terms of infrastructure, your internal network infrastructure is kind of as important as your external infrastructure. So the infrastructure going from New York to Chicago is very important, but even your between the different machines that are involved in your trading, the network is very important. And so to that end, if you are if you implement a system like Altius, where we're talking about using multiple nodes and machines that talk to each other to make things faster, because it parallelizes data access and also improves caching behavior, the network there is somewhat important. If you can make sure you guarantee a 5 gigabit or a 10 gigabit link between your hosts, which is not that expensive, but it does take a little bit of thought to put into that to make sure you do that. So at least then you are operating at a kind of maximum capacity, and hopefully after that, what you kind of mentioned, what HFT already does is maybe network links that are used for blockchain information traveling back and forth across the globe will get better and more reliable, more dedicated, if you will. But that is not a problem that's easy to solve without the money being there, and the money here is not centralized, right? It's decentralized amongst many players. So that will be a more difficult problem to solve. But at least within your own tiny slice of the world, whether you're an L2 or even an operator in L1 space, you can make yourself faster by focusing on that.
What you address makes me think and raise another question, maybe out of the sudden, is why everyone joins crypto post HFT. So you've mentioned about the folks from Double Zero, Solana, so Monad. I think we can keep going with the list of bright minds in this industry. Is there anything similar in particular, apart from what you've mentioned, what is not hidden on the top and like not seen on the top? So maybe you can mention and give us highlights on the reasons why you think this is a very nice and similar space where you can build.
Yeah, I think you might be disappointed with my answer, but I think I mean, look, I think a lot of the people that are coming over from HFT, at least kind of the names that you just mentioned, they're pretty seasoned engineers and seasoned HFT people that were in that space for a while. So honestly, like, just as in anything in the world, right? It's not like HFT got less interesting. It's still incredibly interesting. They're still trying to, as I mentioned, now they're shaving off nanoseconds. They're no longer working at millisecond or microsecond levels, right? So, I mean, heck, maybe they're looking at the next slice up. I don't even know, because I haven't been in the industry for a little while. But my point is that some people want to do that and just keep doing that. And I think a lot of people just wanted a new challenge. Like, anything in life could become a little bit old and stale. And some people it doesn't, and some people it does. For me, I was, again, 14 years. So it's not like I was there for 2 and I left. I did a good amount of time there, as well as some of the other people involved in some of the endeavors you just mentioned, Ivan. And so that's one thing. And then the second thing is, like, as I mentioned earlier, that this space is kind of ripe for some of these new ideas to flow in. So the baby steps I was mentioning to be able to take to speed things up. And so I think a lot of us are excited to come from that background where we had some experience with that and then apply it to a new space. It doesn't mean, all of our lessons from HFT may not translate to blockchain, but I think that's part of the challenge. And some of us just want a new challenge.
I think maybe the last question to conclude is that, based on my understanding, Web3 doesn't have order books in the same way, but mempools kind of play the similar role, right?
Yep.
Yeah. So can you please walk us through how those two world compare and what's the role they are playing?
Yeah, I mean, there's, obviously, we hope one day there will be a spot order book on chain, and we know that that's extremely difficult because chains are not that fast. It's just a huge amount of state with a lot of contention. So that that again, that's hopefully down the road that all of our improvements can maybe enable that to just work and happen. But yeah, I think that's a fair analogy, is that the mempool is a sitting pool of transactions to be executed in a similar way. Obviously, the order book in the HFT world is which order is going to be executed against what other order. It also stored all in memory in a mempool of its own sort, I guess. But I think where the two diverge is that one is I guess the order book is very structured, and so you can optimize the heck out of it. I mean, you can really do a good job of optimizing it. And as I mentioned, they have HFT has gone to really high, have gone many lengths to try to optimize that, whether it's adding hardware to the solution or whatever, right? And I think that's where the kind of analogy breaks down, is that's really tough to do when you have such different heterogeneous transactions and contracts, new things that can be added to it at any day, right? Like in HFT, the order book, first of all, it doesn't change for months or years. It's the exact same data structure that is there. And then, it's a big deal for an exchange just to even add a field or something like that to to the order structure. Versus here, anyone, you could have a completely different set of smart contracts running every day, right? And so every hour, right? It could just be whatever runs at 8 a.m. to 9 a.m. is not going to run ever again. So that becomes a little bit more difficult. I haven't looked at the problem very carefully, since I'm kind of heads down working on this problem in terms of execution. But I bet there is a lot of stuff that people can do there to make it faster. Unfortunately, I am not the expert on that area, but hey, if we can solve this execution stuff, I'd love to take a look at that next.
That's fine. I think people will ever even admire, given that you've mentioned that you're not an expert in something. I think not everyone can accept that and truthfully say so. That's fine. There is still a room to learn from for all of us, and for you as well. So that's the beauty of the challenge. I think on this note, we're gonna wrap up for today. So there is clearly a takeaway that a lot Web3 can borrow from HFT, especially when it comes to performance and scale. And I hope that this episode sparked any ideas or questions. So we would love to hear you in the comments, guys. And if you haven't already, like, subscribe, and turn on notifications so that you don't miss any next deep updates. Because we are on the way to actually make some beautiful updates. Thank you for watching. Thank you, Anit, for taking your time to explain this. And we'll see you in the next episode.
Thanks, everyone, for joining. Take care.